Hello everyone, this is Ming. In this video, we are going to go through the hands-on part of big data platform using Spark. At the course homepage, in the notebook section, there is a notebook for big data platform. Let's first copy the address for this notebook. Once you copy the address, let's go to the Databricks Community Edition. First, we are going to create a cluster. I'm using test01 as the cluster that I'm trying to create. It's going to take around less than 1 minute for the test01 cluster to be up and ready. Meanwhile, let's click the workspace on the left and home on the left. Then we're going to see this all the notebooks that I have in my account. In this space right here, right click and click on the import URL and copy and paste the link address that we just copied and click import. Okay, so this is basically the notebook that is already in your own computing environment. You can modify the notebook, run the notebook. Before we can write, we need to attach the notebook to the computing environment that we just created. Okay, it is attached. Let's click on the Run All button here. It is going to run from the beginning to the end for this notebook because it takes a little while to install and load all the library, and we just let it run, and then while it is running, I'm going to go through the details of how each cell is actually the purpose of each cell. So first, we need to install the Sparkly R library. We first install that and then load the library. And after we install and load the library, the first thing we need to do is actually to create a connection. The connection is basically between the notebook's local environment to the Spark system. And basically, we can see that notebook is running, the R notebook is running on some local computing environment. And because it is the R environment, so we can install and run any R functions and R libraries without any limitation. But on the other hand, the Spark environment is separated from this R notebook. But based on this connection we created, we can actually connect a connection between a local R object to the Spark data frame. Basically, we are going to apply some of the dplyr and some functions and some machine learning functions to this local R object. It is actually going to drive the same operation, same functions to the Spark data frame. So basically, we cannot run any functions from the local R notebook to the Spark. We can only run functions that is part of the dplyr library and some of those machine learning functions that is already part of the Spark system. So the first thing, we create the Spark connection by call this Spark_connect function here. Then we are going to load the library dplyr. Within that library, we do have a arrays dataset. And by looking at the arrays dataset in the head, we're going to see a few lines here. Here, arrays is still our local data frame, so we can apply any functions to it. And because the Spark system computing environment is freshly created, probably in your environment there's no Spark data frame at all. It is empty. So what we're going to do is going to copy the ARIS dataset into the Spark system using stf underscore copy underscore tool, and using the connection we just created. So basically, after we copy the ARIS dataset to the Spark data frame, then there will be a Spark data frame with the name ARIS, which is basically has the dataset, the ARIS dataset. But meanwhile, in R, we created the local R object. It is called ARIS underscore TBL, and the connection has been created between this R local object to the Spark data frame ARIS dataset. So in the future, we're going to apply R operations, primarily dplyr operations, to the ARIS underscore TBL local R object. But the effect is actually driving the Spark's distributed computing environment to perform the same operation to the Spark data frame ARIS. So the src underscore tbls function is going to show what is the Spark data frames in the Spark system. And here we do see the ARIS dataset that we copied to, and there are actually two more which is not related to this notebook that I created in the past. So basically, to analyzing the data, the Spark data frame, or do some aggregation functions to it, we can use any or nearly any of those, nearly all the functions in dplyr package, such as we can count how many rows. We can also return the head of the few rows, as well as some more advanced data manipulations, like creating a new variable, group by, and summarize. All those are actually the dplyr functions that we can apply directly. Even though we're applying to the ARIS underscore TBL function, ARIS underscore TBL local R object, but the effects is going to be using Spark and driving the same operation to the ARIS Spark data frame in the Spark environment. Once we finish the pre-processing and the aggregation, we can actually collect the result to a local R data object, ARIS underscore summary. So that's basically a reduced data set that can be fit in the local R notebook computing environment memory. And that's actually is typically done. So we're not going to collect the entire data set in the Spark data frame. And very likely it is going to be huge. But we can collect a subset. We can collect a aggregated information back to the R local page. And based on that, based on the reduced data, we can apply any R functions to the local data frame. In this case, the ARIS underscore summary data frame. So as you can see, those are the reduced data set we collected. And then, as I mentioned earlier, once we have a local data frame, local R object in this notebook, we can apply any functions from any library to it, same as our the typical R installation on your own computer. Like, for example, the ggplot function to the ARIS underscore summary data frame. One of the largest advantage, in addition to can call any of the dplyr function to a Spark data frame, is we can feed typical machine learning and statistical learning method to a Spark data frame. Those include like linear regression, k-mean clustering, etc. To fit those models, it has a specific functions in the Sparkly R package, Like for example, in machine learning, the linear regression method, it is ML underscore linear underscore regression, and we define the local R object referring to the Spark data frame, and then we define what is response, what is features, and then it's going to feed a linear regression. So this is not bounded by memory. So it's actually everything's happening in Spark. So you can have billions of rows in your data. You have like a few hundred features, no problem. It's going to feed a linear regression very quickly using the Spark environment. We can also feed a k-mean clustering algorithm. In this particular one, we're calling ML underscore k-means. We're still using the arrays underscore TBL, the local R object. K is the number of clusters we want to feed, and then what are the features we want to include it in the feeding. And then after finished, it's going to return basically the three cluster centers. We can also using the ms underscore predict function to predict which group the data is actually belongs to for each row, and then we collect them back as a prediction local R object. Because the prediction is a local R object, we can then apply any functions on top of that from any library. Like for example, the ggplot function is going to plot the data and the group and the centers for each group. Okay, that's basically the hands-on session for this big data cloud platform using Spark. So in summary, we actually create a connection between our local object to the Spark data frame. And any functions from the dplyr library can be applied to the local R object. And the effects is going to be actually all the operation is going to using Spark to the Spark data frame. And we can also feed a typical statistical and machine learning models to a Spark data frame by calling the specific functions that is provided in Sparkly R. And unfortunately, we cannot apply any functions from any library to the R local object. It is only for dplyr functions and a few of those statistical and machine learning functions.